we want to use the Cauchy-Riemann equations to find out if f of z is equal to e to the negative 3x cos y plus I sin y is analytic. Alright? To use the Cauchy-Riemann equations. Now here, let's expand the bracket first. To separate these, we need them to be separated, the real part completely separate from the imaginary part. F of z is equal to e to the negative 3x cos y, that's the real part, plus e to the negative 3x, no, plus I e to the negative 3x sin y is the imaginary part. Alright? Now, here, remember, you generally have the equation in the form of x is u plus vx, where u is the real part and v, the imaginary part. Now remember, what the Cauchy-Riemann equations say is that when you differentiate partially derivative of u with respect to x,
yes, Matthew,
this is equal to derivative of v with respect to y. Alright? And derivative of u with respect to y is equal to negative derivative of v with respect to x. So here, partial of u with respect to x, right? Oh, why write this? Why write it like this? It's iv of. Alright, let me write it properly. Let me just write it properly. Shouldn't bother try to use the shortcut. So if you have u of x on y plus I v of x and y. Because the function u can contain x and y in it. The function v can contain x and y in it. Alright? So now, here, the partial derivative of u with respect to x equals the derivative of v with respect to y, and derivative of u with respect to y is negative derivative of v with respect to x. Right. So now, those are the Cauchy-Riemann equations. Obviously, u is negative 3x cos y and v is e to the, no, well, u is e to the negative 3x cos y and v is e to the negative 3x sin y. Now, I want you to pause the video and finish this thing off for me. Have you done that? Alright, so you've done that. Let's see what happened here. What will happen? U is e to the negative 3x cos y and v is e to the negative 3x sin y. Right? Now, the thing is, you're going to find the partial of u with respect to x. So partial u by partial x is equal to, use your chain rule, because you're integrating a function of a function, right? E to a function, and that function is negative 3x, and e to something is itself a function. And of course, cos y is just a constant because you're considering y as a constant for now. So you can say this is cos y times, if you differentiate 3x with respect to x, you get negative 3. So it's negative 3 cos y e to the negative 3x. Okay? What about partial v by partial y? This is the one we're comparing now. If you differentiate these with respect to y, you know that when you differentiate sine, you get cos. So this is going to be cos y e to the negative 3x. Now, you can see here that these are not analytic. The equation, I mean, is not analytic, or the function. Alright? You could also test it with this other partial Riemann equation. If you find partial u by partial y, partial u by partial y is, when you differentiate this with respect to y, you're going to get negative. When you differentiate cos, you get negative sine. So negative e to negative 3x sine y. What about partial v by partial x? This one. Let me put a negative in front of it from now. It's supposed to be. Okay. Let's see now. Now, delta v by delta x, partial v by partial x. This is going to be negative 3 times, so it's negative 3 e to negative 3x sine y. Now, of course, here, this would be a positive delta v by delta x, but I want it negative. So I'm negative it. Right? When I negative the negative, I get a positive. Now, of course, again, you see that these two equations are not satisfied. These two functions, this equation is not satisfied. Neither of them is satisfied. So the function is not analytic. Alright? And that is shown using the Cauchy Riemann equations.